In this tutorial, I am going to show you how to evaluate genome assemblies using BUSCO. And so by the end of this tutorial, you'll be able to generate this figure that is being shown right now. Now, let's get started. So for this tutorial, we are going to first install BUSCO, and then we are going to download an example data, and we are going to evaluate the genome assembly that we will download. So basically, that's what we are going to do. And then we will generate the visualization, the one I showed. And let me also say that the ebook as well as the script for this tutorial are all available on my Patreon channel. So check the description box for the link, and then you can use that to get the materials. So take note of that. Now this video is an introductory one, and so I will encourage you to visit this page to read more about BUSCO. You should also visit the user guide page here, which has the usage instructions, and you should also visit this page, which has a protocol that you can use for using BUSCO or running BUSCO. So I'll leave the link to all these pages in the description box, so take notes. Now for this tutorial, if you are going to follow it, you need to make sure your PC satisfies this requirement. You should have a Linux PC, and you should also have Mamba or Micro Mamba installed on that PC. I have tutorials that show how to set up Mamba and Micro Mamba, so check the description box and you'll find links to those tutorials. So let's get back to the terminal and then start the exercise. Okay, so we are on the terminal now. So on the terminal, I assume that you have installed Mamba or Micro Mamba, but I'll use Mamba, by the way. So we will need to first create an environment and install BUSCO in it. So I'll say Mamba create-n, and then I'll say BUSCO. So this is the name of the environment. Now let's also install BUSCO. So I'll say BUSCO. So this is it. And then we are going to add channels. So I'll say -c, bioconda -c, under forge, and then -c, defaults. I'm going to add these 3 channels. So once we do this, we can execute. So let's execute this command to install BUSCO. Now let's type Y to confirm. So once we do that, Mamba will download all the necessary packages, install, and configure them for us. So let's wait for everything to get done. Okay, BUSCO has been installed. So what we are going to do next is to activate the environment. So we will use this command to activate the environments and then run BUSCO. So if you installed BUSCO using Mamba, then this is how you activate it. If you install using Micro Mamba, then you have to add your micro to this command here. Alternatively, you can run BUSCO directly by indicating or specifying the environment using this approach. But I will use this approach, so take note of that. Now let's clear the screen and then continue. We are now going to activate the environment. So I'll say Mamba activates BUSCO. So this will activate the environment for me. So once the environment is activated, I'll find the name on the left side here. So that's it. Now let's take a look at how to use BUSCO. So visit the user guide page, which is here. The link is in the description box, by the way. So when you are here, visit the Run BUSCO section. So click it, and then you will be sent to this section here. So we have some arguments. We have BUSCO, that is how you call BUSCO. You specify your sequence for using this approach. You indicate the lineage, you indicate the output, and then the mode, and then other options. So these ones are mandatory. You have to do that, and then the other options, that one is up to you. For this tutorial, we will use the mandatory arguments, and then if there's a need, we will specify other options. So that's how we will do it. So let's take a look at the example data that we are going to use. I have it on one of my GitHub repos, which is here. So these are genome assemblies, and there are 4 of them. So these are Salmonella genome assemblies. So visit this page. The link to this page is also in the description box. So when you are here, click the file, and then you'll be sent to this page. So when you are here, come to the right side to download. Click on this download raw file button here, and it will be downloaded. Because I'm working on a terminal, I will get a download link. So what I'll do is to copy. So I'll say copy raw file. So I'll just copy it. Alternatively, you can just right click the raw and then also do the copy link. It's the same thing here. So once you are done, you can download. So let's go to the terminal. So on the terminal, what I'll do is to create a working directory. So I'll say make the BUSCO project, and then I'll cd into it. After that, I will download the example data. So I'll use wget. I'll say wget, and then I'll supply it with the link. So this is it. So I'll execute this command. Okay. So the zip file has been downloaded. So let's take a look at it. Let's do an ls, and we are going to find it's here. So we are now going to unzip it. So I'll say unzip genome assemblies. So if I do an ls, I'm going to find my file. So I have 4 FASTA files, and I also have this one here, this tst. So the tst file here gives description. So I'll say cat file info.txt. So this gives you the genome assemblies, the isolates, the data. So for each of these files, we have 2 links that you can use to get more information about that particular data. So that is what this tells us. So that's it. Now let's do this. I have my FASTA files, 4 of them. That means 4 samples in this context. So what I'll do is to create another directory and then move these files into that directory. So I'll say make that, and I'll say genomes. Or you can also use, let's just do this. Let's use this. Okay, let me just do it again. So I'll say make the genomes, and then I'll move all the FASTA files into that directory. So I'll say mv star.fasta, and I'll say genomes. Yeah, so we have moved them. So if you do an ls, you see a directory called genomes, and then in that directory we have our files. So I'll say ls genomes. I'll find my FASTA files there. So that is how we do it. Okay, now it's time to run BUSCO. So I'll start with one of the files, this one here. I want us to start with this one. Now, before we test BUSCO, let's take a look at something. It's very important. Now, when you are running BUSCO, you have to specify the lineage, which is here. So the lineage, BUSCO allows us to specify a particular lineage. So we can actually list all the lineages available, or let me just put it, the databases available that BUSCO can use as lineages. So we will list that first before we even evaluate our data to get the lineages or data sets or databases. So to do that, I'll say BUSCO -- lists, and then I'll indicate this one. I'll say dash data sets. So this will list all the data sets for us. So we have all of them here. So if you're running BUSCO, then you can specify any of them. It depends on the organism you are dealing with, by the way. So if you are dealing with bacteria and you are not sure of the species, you can just list bacteria. Or if you are sure of the species, then you can also look into the list here and then select the appropriate one. So that's what we have here. So each of these can be specified. Now, let's take a look at our data. So our data is made up of Salmonella enterica assemblies. That's what I have here. And so let's take a look at the taxonomy. I think I have a page open for one of them, which is this one. The link to this page is also in the discussion box. So let's take a look at the information for this particular one. So we have that here. Let me just go back. I think I'll start from here. That will be better. So it's this one here. This is the strain. So to get the taxonomy, I use the bio projects. So I click it and then I'll be sent to the next page. Which is here. So when we are here, just check on the organism section and you find the taxonomy. So we have the taxonomy here. Okay, so we have that here. So you can check the information here and then look them up. Ideally, we can go for the lowest one. So we can check here in the list to find where it is and get its ID or name. So with bacteria, let's take a look at it. Bacteria, and we also have this. So we can check them here. So I've already done the test. So I'll scroll down to where the information is. So when we are here, this one here, you select this one here. So this is what I'm going to use. So this is more specific. Okay, this one here, everything here. Yeah, that's what we have here. That is what has been stated here. So this is the lineage I am going to use. Of course, if you are not sure, you can also use the auto lineage, but that one is for another tutorial. But for now, since we know the lineage, we will use it. So this is the lineage. I'll just copy it, by the way, and then use it. So that's what we are going to do. Now, let's continue. Now that I have that information, it's now easier to proceed because we will need that. Let's into genomes again. We have that here. So I'm going to run BUSCO on one of the data sets. So I'll use this one here, this assembly here. So let's go back to the BUSCO user guide, which is here, and I'll run BUSCO. So what you should also note is that we have -I sequence file -L lineage -O -M and other options. So you can even decide to bring -M first, followed by -O, this. It doesn't matter the arrangements. So just take note of that. Now let's go back. So we'll go back and then call BUSCO. So to call BUSCO, that's what I'll do. I'll say, let me just repeat again. So to evaluate a genome assembly using BUSCO, you need the lineage, which I've already indicated, by the way, but we will just do it again here. So to evaluate a genome assembly using BUSCO, you say BUSCO, and I'll say -m, genome, that is the mode. I'll say -I, and that will be this one here. I'm using this genome assembly. So I'll say genome / and I'll indicate that file. And then I'll say -O, and that will be CVM underscore N31384. I just want to use the same name. And I'll say underscore BUSCO. And I'll say -I. And I'll say -L. That is the lineage, by the way. And I'll paste the lineage. This is the lineage. I'm going to paste it there. So this becomes our final command to evaluate that assembly. So let's proceed. So let's execute this command to evaluate that assembly. So once we do that, BUSCO will download the necessary files and then use them. So let's wait for BUSCO to complete its work. And by the way, with the data sets, i.e. the lineages, you can also download them locally and use. But for now, because we have not downloaded it, BUSCO will download that and then use it for us. So let's wait for BUSCO to complete its work. Okay, BUSCO has completed its work. So this is the result summary. That is what we are going to focus on. Now let's take a look at the user guide page. So there's a section that can help you to interpret the results. So we have that here. It says interpreting the results. So click it and then you'll be sent to this session which gives you more information. So what BUSCO does is that it puts the result into categories. So we have complete and single copy, complete and duplicated, fragmented, and then missing BUSCOs. So we have details here, so you can just read about them here. Now let's get back to our report summary. So we have the report summary. So the C here represents complete BUSCOs. And so we have 99.1% complete BUSCO. So this is the breakdown. So we have complete and single copy. And then we also have complete and duplicated. So all of them in total gives us 99.1%. And we also have fragmented, and we also have missing, and we also have N. That's the total. That's what has been given here. So ideally, we should have a high percentage for complete BUSCOs, and that is what we are seeing here. So this lets us know that the genome assembly is good. So this is one way to evaluate the assemblies, and you can also examine the individual files. And by the way, let's take a look at the files. I think I'll open a new tab now. So I'll do an ls. So this is the directory which has the output files. So you can ls into it, and then we can look at the files here. Now, the description of the files is also available. So on the user guide page, let's just check. There's a section for it. Let's see. Yeah, we have the output here. So click the output, and then you have a description of the files here. So a detailed description is beyond the scope of this tutorial, but I will encourage you to read that here. You can also use your file manager. Let's open the files. So this is the output. So I can open it and then check the files here. So there's a short summary. This is what was displayed for us. And we can also check this lineage. This is what we specify, by the way. And then you can check the short summary, missing BUSCO list, and then the full table. So there's a full table. You can check it if you want to probe further. So with the full table, you have your genome assemblies. You have the context, by the way. So that's what you have. You have Let me just enlarge it a bit. So you have, for each config, if there was a BUSCO hit, it will be indicated. So for example, this one is a complete BUSCO. So that gen was found on this config. And then we have the start and then the end, and the score length. And you can also use this link to look up that hit. So all these things you can explore further. That is beyond the scope of this tutorial, by the way. This is an intro video. So I'll skip a detailed explanation of all these, but I will encourage you to check them to understand your data. Now let's get back to our terminal. So we have the summary here, by the way. But then what happens is if you are dealing with multiple samples, like in this case, let's ls into genomes. We have multiple samples like this here. We have 4 samples. Then it becomes much easier to compare them and also understand your data if you generate visualizations. Of course, this one was a single sample, so having the summary here is good. We can easily read and then make sense out of it. But if you have multiple samples, then trying to read the summary for each and then making sense can be a bit cumbersome. But one way to make your work easier is to generate visualizations like this one here. And so that's what we are going to do. What we are going to do next is to run BUSCO on each of these files. And then we are going to aggregate the summaries and then generate a visualization for that. And then we can just have a discussion on it. So to do that, let's take a look at how BUSCO does it. So on the page here, this user guide page here, so just scroll down to this session, companion scripts. So click it and you'll be sent to this section here. So scroll down to this session here, and this tells you how to generate this visualization, this plotting. So that's what we are going to do next. So of course, because we installed BUSCO using Mamba, all the necessary packages have been installed, so we can run it straight away. So what we need to do is to run BUSCO to generate the outputs, and then we'll copy the summary files. We will copy them all into a single directory, and then we will run a Python script to generate the trigger for us. So that's what we'll do. So there's an example here. So we copy everything, and then we run the script. And then we specify where those summaries have been stored. So we start from here, we create a directory, we copy all the summaries into that directory, and then we execute the scripts, this Python scripts here. So that's basically what we are going to do. So don't worry, we are going to go through that, and I'll also show you a strategy that you can use if you have multiple files or multiple samples. So let's get back to the terminal. So let's use this one. Right. So let's clear the screen and continue. Okay, so let's ls into the genome directory again. So we have 4 files here. So what we are going to do is to create a bash script, and then in that bash script we will indicate all the necessary commands that we will use. So that's what we are going to do next. So let's do this. Let's create the scripts, and of course you should also make sure you know the directory that has all the necessary files or input files. Of course, we have this one here. So we'll create a script. So I'll say nano run busco.sh. You can use any text editor, that is fine, but I prefer to use this one. So I'll have it open. So I'll indicate my shebang line, and then I'll come to this side. So what I'll do first is to create a directory called BUSCO summaries. Let me just add this, create a directory to store the summaries. This is what I have done here. And then I'll now also define the lineage. So I'll say lineage equals this. Let me add this. So after that, I'll now use a loop to iterate over each of the files and then run BUSCO on them. So I have 4 files here. So this is where loops come in handy. So if you have 4 files or more than 4, then it's important to use loops. And you can write a generic command that factors the names here. So I have 4 files and I know their names, by the way. So I will say for sample in, and then I'll indicate the names. Okay, I have the names here. So I have this, I'll just put all of them here. So this is one of them. Let's add just the names. I'll just copy them because these are few. But if you have, let's say, 20, 30, 50, or hundreds of files, there are better approaches to do that. And if you have such a situation, you can always reach out to me. So for these ones, I'm just doing a copy and paste just to get them. So I have them. And you should also notice that I did not specify the .first A. I'll indicate that later on, but for now, I just want the names. So this is where it's important to also have a good naming convention when you are doing bioinformatics analysis. When you have lots of samples or lots of data sets, then having a good naming convention allows you to easily automate the analysis process or analysis pipeline. Okay, so I have them here. So for sampling this. So I have 4 files. Then I'll say do. So the do should be lower caps. Then I'll just say BUSCO -m, and I'll say genome, that is the mode. And I'll say -i, that'll be genomes/, now I'll do this $sample. So $sample here is this one. So because we have 4 files, each of them is this one. So we are creating, so at a particular point in time, the sample referred to this. At some point in time to refer to this. So that is what this dollar is. So the $sample here indicates the actual name or the actual value. So in this case, our sample names here. And then I will say .first A. So we have the genome directory, and then we also have the sample, and then we also have the extension .first A. So that is what I have indicated here. And then I'll say -o, and I'll say $sample _ BUSCO, and I'll say -l, then I'll indicate the lineage. That will be $lineage. I define that here. What else do we have to add? That is it. Now, what we need to do next is to copy. If you take a look at the instructions here, after generating the BUSCO outputs, we need to copy some files. So we have this one here, short summary, blah, 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 blah. Now, let's take a look at this. I think I have mine opened. So when we are here, we need to copy this one, this file here. This is what we are going to copy. And that is the next command we will indicate. So that one will be here. So I'll say cp $sample underscore BUSCO slash, and I'll say short underscore summary. And then I'll say dot star. Let me bring a quote here. It's quotes dollar lineage. Dots dollar sample. And then I'll say star dot txt. And then I'll say BUSCO underscore summaries, because I am copying it. I'm copying the summary file from the output. So that is how we will do it. And then that will be done. So this is how we will run BUSCO to evaluate all the assemblies that we have. And then we also make a copy of the summary into another directory. So let's execute this command, or let me just say, let's execute the script, because now it's a script now. Okay, so we are done. And then let's do an ls, and we are going to find this file here, which is the bash script. So we can say chmod +x run busco.sh to add execution rights. Now with this sample, we already generated a BUSCO output, which is here. And so if you run BUSCO indicating the same directory as the output, then you have an error. So what you can do is to put this output somewhere or remove it completely. I am going to remove it completely. So I'll just say rm-fr, then I'll call it. Now you should be careful when using the rm command. I repeat, you should be very, very careful, because once you execute it, you cannot recover your files again. So you should be very, very careful. Okay, so what I want you to do is to make sure that you review whatever you are going to delete before you run this command. So I am going to remove this directory first, and then I am going to run BUSCO again. By this time, I have it in this script, so that's what I'm going to use. I'll just review the command again to make sure everything is okay. And now I'm going to run it. So I'll say with the run, you can say // and then you specify the script. This will work. You can also use bash, then say run underscore busco.sh. I will use this approach, by the way. So let's execute the script to get the output for all the samples. Perfect. So now BUSCO has started this way. So let's wait for BUSCO to complete, and then we can proceed. Okay, BUSCO has completed the evaluation for the genome assemblies. So let's take a look at the outputs. So let's do an ls, and we are going to find some directories. So we will have this directory, BUSCO underscore summaries. So this directory has the summaries for the 4 samples. So the 4 samples, these are their respective outputs. We have this, we have this, we have this, and we have this. So these 4 directories are the output for the 4 genome assemblies. So let's list just those outputs. We can say ls -d, and we say *_BUSCO. So this will list just the directories first. So the directories for the 4 samples. So the summary for each of these samples has been copied. So they have all been copied into this directory. So let's ls into this one here. I'll say ls BUSCO_summaries, and I have them here. So it is from these summaries that we will generate the figure that I showed earlier on. So what we are going to do next is to visualize the BUSCO results. So that means we are going to generate this figure. So to do that, we need the summaries, which we have, by the way, which are here. And we also need to execute a Python script, which I showed earlier on. So we will say generate _plots.py, and we say -wd, and we specify the BUSCO summaries directory, which is BUSCO_summaries. So let's execute this command. So once we do that, the figure will be generated. So the Python script we executed will aggregate all the summaries and then generates the plot for us. So now let's take a look at the output. So let's do an ls again. The figure will be found in the BUSCO_summaries. So you can say ls BUSCO_summaries. We are going to find the figure here. We also have this R script. Now let's open this file. So I am going to use my file manager. So this is a directory that has the summaries. It also has the figure. So let's open it, and we are going to find our figure here. There's also this R script here. This is what was used to generate the plot. You can open it and then check the codes. So that is here. I'll close it. Okay, now this is the figure that we have been waiting for. So let's open it. Perfect. So this is the figure which has the results. And so once you have it, it becomes easier to compare them and also make sense out of the data. So ideally, we should have a high percentage of complete BUSCOs, and that is what we are seeing here. So looking at the color scheme here, we see that a high percentage of the genome assemblies are complete BUSCOs, which is very good. So for the complete, we also have the breakdown. I talk about it, and this is how we do it. Now you can also add more samples. So here we had 4 samples, and I showed you how to automate the process. But the process I use, or let's say the approach I used, may not be appropriate if you have, let's say, 50 samples or 60 samples or hundreds of samples. So in that situation, there is a better alternative. So if you have such a situation, or if you have lots of data sets that you want to run BUSCO on, and then you're having challenge, you can always contact me and we can arrange a session together. Now, after genome assembly, there are a number of activities you can perform, or let me just say analysis. So here, this is a non-exhaustive list of things you can do. You can perform genome annotation, you can call variants. If you're dealing with bacterial genomes, you can perform pangenome analysis, etc. So check the description box, you'll find tutorials that can help you to analyze your data after genome assembly has been done.